Hi all, this is a short course on Introduction to LTspice Simulation. In this course, we will do for particularly what is LTspice, a brief history, why use LTspice, key features, installations and getting started, the LTspice interface, a tool, basic circuit simulator, DC analysis, transient analysis, time domain simulations, etc. to getting familiar with the LTspice. Okay, so what is LTspice? This is a simulation program with integrated circuit emphasis. This was developed at the University of California, Berkeley in the 1970s. It is a powerful and general-purpose analog electronic circuit simulator. It solves circuit equations to get the required results. Used by electrical engineers to predict the circuit behavior before building a physical product. This is particularly useful if you are doing an electric circuits. If you do simulations before going for the practical, you will get an idea of what is happening inside the circuit. Instead of doing all these circuit elements, if we can do a simulations, you get a better idea about electrical circuits. Okay, so why to choose LTspice? It's free, fully functional and completely free to download and use. It's a powerful, highly efficient and robust simulation engine. It's user-friendly, intuitive interface for schematic capture and waveform viewing. Extensive library including larger library of passive components like resistors, inductor and capacitor, op amps, transistors and etc. It's a widespread use, industry standard tool for many engineers and students. Okay, so we'll start with how to install LTspice. You can go to this official site of Analog Devices website, which is this site www.analog.com. But LTspice you can search in the Google bar, Google search bar, and download the appropriate version for your operating system, and run the installer and follow the on-screen prompts. LTspice is a lightweight application and installs very quickly. Once installed, you can find the shortcuts on the desktop in the start menu. Okay, this is the screenshot of one of these LTspice, and you can see that there is a toolbar where normally you can find the file, edit, etc. Here we can create new schematics, etc. Here this is called toolbar, and we have a component list palettes, which is where we can actually get different type of components, resistors, capacitors and inductors, and you can get a wider range of components from using this tool. And most of these electronic components you can get it from these type of tools. And this is a waveform viewer. Before that we have a schematic editor where you have the first thing is you have to do the circuit in the schematic editor, where you can wire these different type of components. After getting from different component palettes, you can wire it using this wire, and after wiring is completed, and you also add this always add this earthing components also, then the circuit is completed. After this you can do the simulations. Here you can view the simulations in the waveform viewer, where you can actually see different type of waveforms and the required input or output, whichever you want to view. Okay, if you look at the different type of simulations, LTspice provide different type of simulations like a transient analysis, ACU analysis, DC sweeps, noise, DC transfer, DC operating point, and transient frequency response. Most of these have different type of parameters. You have to select the appropriate parameter for doing such analysis. Okay, we will look for some of these important modes of simulations. First we look at a DC analysis. Its purpose is to find the DC voltages and current in the circuit with a steady DC source. So if we have a simple circuit here where you have a DC source and we have an ammeter here, and we have some two loads here. Okay, so in this steady state we just apply a particular voltage here, then you can find different type of current in the circuit. This type of analysis is in DC analysis. Another analysis is called a DC sweep. So last circuit what we do is we do a fixed voltage source, Instead of this, we have using a varying voltage source and simulating circuit with a single DC sweeps let you simulate a circuit with the source voltage current stepping a wide range of values. You might sweep a voltage source from 0 to 10 volt in steps of 0.1. Actually, instead of giving a constant voltage, you are actually sweeping your voltage and you are finding the response. Maybe there may be the output voltage or output current. You can get it and get a graph from his. Okay. So in this step, you have to give the initial voltage, final voltage, and the number of steps you needed in the boxes provided for the DC sweeps. The another one is called a transient response. The purpose is to see how voltage and currents changes with time. Essential for understanding the circuits with the capacitors, inductor, and time varying circuits. Looking at this circuit with an LC oscillation circuit, we have a inductor and a capacitor, and also we have a switch. If you switch on the switch, what happens? The current or voltage in the circuit will be varying with the time. So for the cases of signals which are varying with the time, transient analysis are much important. And we can see if you switch on this switch, what you can see, what is the variations of voltage or current with time. We can plot using the transient response. Okay, another one is called AC analysis, frequency response. The purpose is to analyze the circuit's behavior over a range of frequencies like filter circuits. Okay, what we're doing here is we will vary the frequencies here in the x-axis and see what is the voltage or amplitude of the voltage or current will be varying. So this is particularly looking for the amplifiers. If you change the frequencies will get a maximum value some frequencies, and it may be decreases on the both end of this of the frequencies.